I will take an Arduino Nano as it is small and can fit on a breadboard. The HC05 Bluetooth module has in total 6 pins, of which we will only use 4: the VCC, ground, RX and TX. And like the Arduino, I will just place it on the breadboard. To connect everything together, jumper wires will be used, especially these male-to-male wires which have male connectors on both the ends, like these ones. These wires are coming straight from a fresh pack, so for using them, I counted the number of wires I needed to connect the circuit and separated them from the main bunch. For ease in connecting everything, I flipped the Bluetooth module so the pin markings would be visible. I connected ground to ground of the Nano, VCC to 5V of the Nano. Two wires for the RX and TX are connected to pin D2 and D3. Now I plugged in the mini USB cable to the Arduino. Note that the cable was already connected to my computer. As I plug it in, the power light blinks up and the lights on the Bluetooth module starts flashing. This continuous blinking of the lights mean that it's in pairing mode right now. Before going further, we should understand how these two pieces of circuitry talks to each other and how they exchange data between them. So for that, I am writing a very simple sketch in Arduino IDE for the Arduino Nano, which will initialize the serial port, which is the TX and RX pin of the Nano, and will send a hello string every 2 seconds or so, using the serial.println function. After that, I selected the Arduino Nano from the board selection menu and selected the right COM port and then clicked on upload. After the code has been uploaded, we open the serial monitor and we can see a hello string written. We can see the TX LED on the Arduino Nano blinking every 2 seconds or so. This means the data is being transmitted as per the code written. Now to observe this transmitted signal, let's connect two male-to-male wires to the ground pin and the TX pin of the Arduino Nano. I connected the ground clip of the oscilloscope probe to the ground pin wire and the probe to the TX pin wire. On the scope, I pressed the single shot button to capture any incoming data from the TX pin of the Arduino. And this is how it looks. If we zoom into the data, we can see it has binary ones and zeros, which we can decode in the scope itself by using the RS-232 protocol in the decode function. Set the TX to channel 1 and you can successfully see the data decoded. Note the baud rate in the scope and the one you set in the code should be the same. So basically this is the protocol over which the Bluetooth module talks to and from with the microcontroller. Now let's remove the scope wires and focus on the Bluetooth module. I used my mobile phone to enable the Bluetooth firstly, then search for HC05 in the available devices. Then click on pair. It will ask for a 4-digit code. It usually is 1234, so put it in and the Bluetooth module will be paired. Now go to the Play Store, type Bluetooth Electronics and install this app. When you open up the app, you can see there are many templates for us to start. So let's just go into Connect, Bluetooth and then connect to our Bluetooth module. As soon as it is connected, you will notice the lights have stopped blinking on the module. This means the connection has been established successfully. Now let's go into the Arduino code we require to talk with the Bluetooth module. We are not connecting the Bluetooth module to the hardware RX and TX pins of the Arduino, as you may have noticed, but we are using a different digital pin to emulate the RX and TX pins. This way we can use the serial monitor on the PC and talk to the Bluetooth module at the same time. This code is available in the examples section called software serial. We just need to change a few things. Change the RX and TX pins to 2, 3 and change all the baud rates to 9600 and then click on upload. Now go into the mobile app once again and open up a new template by tapping on the empty space and click on edit. From the terminal section on the right, drag the monitor and the terminal onto the grid. Now going back, tap on the run button. You can see the monitor and terminal which you just added. In the terminal, write anything you want to send to the Bluetooth module. Here I wrote a simple hello message. When I click send, the message appears on the monitor, and on the serial monitor on the computer, we can see the message has appeared. That means we successfully transferred data from our phone to the Arduino using the Bluetooth module. Now let's see how we can use this to make a simple project. I will take a LED and a current limiting resistor of about 220 ohms. Connect one lead of the resistor to ground and another to any random rail on the breadboard. And on the same rail, connect the shorter lead of the LED. Use a male-to-male wire to connect the longer lead of the LED to digital pin number 13 of the Arduino. Let us try to write the code for this from scratch. Firstly, we include the software serial library. Then we initialize the object and name it as HC05 and also give the RX and TX pins as 2, 3. Then we initialize a character variable named as data. In the setup, firstly we will begin the communication by using hc05.begin and write the desired baud rate inside the brackets. In this case, I will leave it at 9600 because the HC05 is configured that way. Then in the loop, we will start writing the code to receive the data from the module and read it. Firstly, we use an if statement to see whether we have received any data or not. If we have, we will assign the data variable to this data we received by using the hc05.read function. Then we will analyze the data we received. If we receive a capital L, the LED which we connected on the pin 13, which is also known as LED/built-in in Arduino, because there is already a tiny LED on board connected to this pin. The LED will turn on. And if the data we received is small l, the LED will turn off. The code is very simple. Now I uploaded it and let's test it out. In the mobile application, I changed the string to send to be capital L. And as soon as I press send, the LED glows up. Now what we can do is go and edit this template and add a button or a switch and edit its turn off and turn on string in the settings to be capital L and small l and run it again. Now when we turn the switch on and off in the app, the LED will turn on or off. This simple project can be scaled by controlling various devices or even your own home lights or appliances. I hope you found this video useful. If you did, don't forget to like, share and subscribe to the channel to see more videos like these. Thanks for watching.